So the wait is over and welcome back to our channel Active Catalysts. In this video, I'll be covering Module 1 CN all important questions. So I have written all the question answers from December paper, June July paper, makeup exam paper, model paper 1 and 2 with solutions and even some extra questions that were taken from the question bank. So you can assume that by studying this, not just assume, this is the truth, that you can study only these questions and score complete marks, that is 20 marks from module 1. So if you have followed me for the last sem, you already know me. So as usual for module 1, I'll not just tell like, okay, this is the question, this you have to write, this you have to write. No, nothing like that. I'll give you the tricks to remember, and also I'll make the concepts easy for you so that you can remember it up to your exam. Okay, so let's get started. The notes will be given, don't worry about that. Okay, first question, this is taken from the paper. Okay, so what is data communication? And also do not worry about the answers, whether this much of content is enough or not. I have written according to scheme of evaluation only. Okay, so what is data communication? Least and explain characteristics and components of communication model. Okay, so data communication, so process of transferring data. Okay, process of transferring data from one point to another. How will you transfer it? Using one communication system. Okay, so that is only data communication, and they have asked you to explain the characteristics. Now what I'll do is I'll not read all the points, I'll just tell you what it means. Okay, so to remember the characteristics, the trick is, see, you're remembering the characteristics of what? Data communication. So DAT, and last one is J. What is that J? I'll tell you. Okay, so the first point is delivery. So as the data communication happens, delivery is important. Why? Because the system must ensure that whatever data we are sending, that should be reached to proper destination. And if like the destination, whatever it is there, right, only the required person must receive. For example, I want to send one data from this point to this point, it should reach to this point only. If it is reaching somewhere else, it is useless. Okay, that you should write in delivery. And when it comes to accuracy, it must be delivered without errors. Remember, accuracy means errors, without errors. So if data is altered, like once you're transferring the data, if something is errored, then that data is of no use. Okay, then timeliness is delivering the data promptly. So in CN, always remember, you should always use one keyword. Okay, so I will always suggest, once you get the time, try to underline the keywords, they'll give you marks. Okay, so in scheme of evaluation also, for writing characteristics, they have allocated 1.5 marks, and remaining whatever you explain, it is for 1.5 marks again. Okay, so then in timeliness, delayed data, especially in applications like videos and audios, they lose their value. Okay, then comes jitter. So jitter is nothing but inconsistency in packet arrival. Okay, so in simple, for delivery, you just remember that it should reach to proper destination. Delivery D, and answer also should be D, destination. Accuracy is without errors. Timeliness is, it should be delivered promptly. And for timeliness, you just try to recall, you're watching the video from YouTube and it is getting struck because due to network issues. Jitter is nothing but inconsistency in packet arrivals. Okay, so then you have to draw the diagram. So diagram is very simple again. See, there is a sender and a receiver. So you are sending one message. Okay, and this is the medium through which message is sent. Okay, see, remember, whenever the data is getting shared, we will have certain rules. Okay, so that everyone will follow the same rules. That rules is called as protocol. Now for each of these components, we have to write the explanation. So in question also they have given components of communication model. So that is why we are supposed to write the components explanation. Okay, first let me take messages. Okay, message is nothing but the data or any information that has to be sent. It can be text, image, or whatever. Sender, the device that sends the message. Anything can send, right? It can be computer or smartphone. Receiver is the device which receives the message. It can be computer or printer. Okay, then transmission medium, the physical path, right? So it can be transferred through wires and all. So that is what they have written, communicated like cables. Okay, if it is wireless, it is radio waves. Okay, then protocol is nothing but it is a set of rules that governs the communication. That's it. Then second question is explain switching, and we have two types of switching, that is circuit and packet switching. So switching is nothing but it is the process of forwarding the data packets in one particular entire network from source to destination through some device. Okay, switching is nothing but it is the process of forwarding the data packets in one big network from source to destination through any intermediate device. That is only switching. Okay, so I'll try to cover in such a way that by looking at the diagram you can even write the definition. Okay, fine. So circuit switching is nothing but you should consider two switches. Okay, so this is nothing but the telephone. Okay, telephone, and here what you can see is this is thick line. That thick line is called as high capacity line, and this thin line is called as low capacity line. Okay, remember, if it is like if one telephone is connected to other telephone, it is called as fixed connection. So this fixed connection we can activate or deactivate. So how to remember this is, suppose if you have a telephone in your home, and if it gets deactivated because maybe you have not paid the bill for the calls, so it can be activated or deactivated, depends, right? So that is the situation. Now what explanation you can write is, first look at the figure. Whatever you can explain from the figure, you have to write it. So this network consists of 4 telephones on each side. Okay, to what it is connected? To switch. So when a call is made, okay, the switch connects the phone on one side to another side, right? Like if you are calling from this phone, it should be connected to someone. That is what I have written here. Then a thick line, remember why we use thick line is for a high capacity. Like if there is only one, if one person is making call to another person, thin line will be sufficient. But if many people are calling, we would require this thick line, that is high capacity line. That is what is written here. Now comes the two scenarios. Okay, first thing is, maybe all these 4 persons are calling to another 4 persons. In that case, we will make use of high capacity line, remember it. And similarly, if only one person is calling to another person, then it is 1/4, or you can just say one line. 1/4 is nothing but, I hope you know, if total is 4 and you are making use of only 1, it is 1/4, right? So that's it. Okay, we have completed now circuit switching. Now we will look into packet switching. And before that, we have to write the disadvantages also. See, remember, for circuit switching, you should always speak with respect to efficiency. That is, it is efficient only when all that 4 are working. When all these 4 will be working during high capacity line, right? So same thing you are going to write here. And if only 1 or 2 devices are active, then it is least efficient. Similarly, the thick line needs 4 times capacity, right? But if you are using only 1, it requires only 1 time capacity. That you have to explain. Now in packet switching, what happens is, remember, whenever you hear the word packet, and if you are doing transmission of packets, always routers will come. Okay, but here it was switch. And I just want to tell you, like, if you watch this video completely, if you understand the explanation and start studying by yourself, definitely you can remember. Okay, you will not waste the time in understanding again. Okay, so let us assume there are 4 computers this side and 4 computers this side. Now, okay, same thing again. These are thin lines, that is low capacity lines, and these are high capacity lines. This thing, okay, this is high capacity line. Now, if I want to send one message from this computer to another computer, I'll take the help of router. So in router cannot send all messages at once. So there is a concept of queue. Okay. So now what you will do is, by looking at the diagram, whatever data you can write, right? Like in this setup, we can see the router which queues the packets. Okay, while sharing that packets. Packet is nothing but the data content. Okay. Now what happens is, we should consider a scenario, okay, where this thick line has twice the capacity of this thin line. In that case, what will happen? See, if only like two are communicating, same thing, okay. If all 4 are working, what will happen? If 1 and 1 is working, what will happen? Just like how we considered 2 scenarios here. Okay, so if only 2 computers are communicating, then they move without delay. But if all 4 start sharing, router will be full, right? The queue will be full. So it will store based on the priority, it will share the packets. So that is what it has been written here. Okay. Now the disadvantages is, when it comes to efficiency, this circuit was low. In case of packet, it is more efficient compared with circuit. Then causes delay when interrupted or when network traffic is heavy, right? So if this traffic is full, until it reaches, queue ಮಾಡ್ಬಿಟ್ಟು ಕಳಿಸ್ಬೇಕು, so it will take time. So it is like delay. That is the one point you should be writing. I hope it is self-explanatory. Then next question is layers of TCP/IP protocol. Okay, by looking at the diagram, don't worry, I'll make a trick for you to remember. I'll give a trick. Okay, the trick is ATNDP. Okay, application, transport, network, data link, and physical layer. Okay, so these are the layers we have named, and originally these are called as, see, physical is nothing but hardware, data link is nothing but the network interface, and the network is nothing but the internet. Okay, and these are the layers that you should be naming. Now like what happens here is, see, remember, these are the layers, right? So we have to explain regarding these layers only. So for that purpose, you should be taking this diagram. That diagram is for your reference and no need to like draw it. Okay, this is the actual diagram you should be drawing in exam. So that is ATNDP. Okay, physically is nothing but what happens in hardware, like that you should write, right? So remember, when something data is getting transferred from source to destination at each layer in TCP/IP protocol, what will happen? Remember, TCP will always have 5 layers. Okay, and when it is when the data is coming from source to destination and it is going from like, let us say, from application layer, then the data will be called as message, user datagram in transport layer. In network it is called as datagram, and in data link it is frames, and physically it is bits. Okay, now what happens in each layer, right? Same thing you have to go on explaining. In notes they have given big explanation which is not required. I have made it easy, so try to understand here. Even if you start studying from short notes, you may get confused. The sentences may not be clear to you, so carefully listen to me. The first layer is application, and the data whatever is shared is called as what? Message. And this layer uses some protocols like SMTP, IGMP, HTTP. Okay, then you should write, okay, like what protocols it will use and all. Then whatever address we share, right? So that address name in this layer is called as domain name, or it can even be email address. And in this layer, the responsibility is process to process communication. Next is transport layer. Remember, the address here is called as port numbers. Here address was called as domain name or email address. Here it is called as port numbers. And for web, like if you are visiting websites, the port number is 80. For mail, it is 25. And the responsibility is end-to-end communication. Why I'm stressing on responsibility is in question they have mentioned what is the responsibility of each layer. In the answer scheme of evaluation also they have written this responsibility, whatever is written in blue ink specifically. Okay, next is network layer. Network means it is like a global address, that is IP. Okay, internet protocol. So why do we use it? Because they uniquely identifies the device communication, right? So here the responsibility is host to host communication. In this layer we use IP protocol. Okay, then comes the data link layer. Here we use the address that is MAC. MAC is nothing but it is a like local address. It is unique. Yes, it is unique to specific device. Okay, like LAN, WAN and all. So ensuring that data reaches from one device to another device specifically. Okay, IP is used globally. MAC is used for sending from one specific device to another specific device. Okay, then comes physical layer. So here you can just write like the transmitting bits from data link layer from electrically or optical signals over some physical medium. Okay. Then comes guided transmission media. So this was the definition written in scheme of evaluation, and this was the like definition given in the textbook. You can write any. So provides one path, right? So that is called as provides conduit from one device to other device. Or in simple, guided is nothing but channels that provide specific path or signals to travel from one device to another. Okay, then explain, they have told you to explain twisted pair cable, 6 marks, right? So 1 marks is for guided transmission media and remaining is for twisted pair cable. So twisted means they'll obviously consist of 2 wires. Okay, that you have to write. And remember, this is made up of insulated copper wire, okay, which is twisted together. Now why this twisting is, it will reduce the electromagnetic interference and it will also maintain the signal quality. In answer, the invigilator will look for this kind of words. This side is insulator and this side is conductor. Now each wire has different function. The first wire, it will carry the signal from sender to receiver, and the second wire will act as the ground reference. Okay, then noise and interference. So since it is twisted, the noise is also minimized. Okay, and this twists, they will reduce the noise. That is why there is a twist. Okay, then in case of twisted pair cables, we have 2 types. One is STP and the other is UDP. Okay, so in case of STP is nothing but shielded. Okay, and this UDP, U is nothing but unshielded. They have told shielded, so it is metal shielded. You can find one extra layer in this board diagrams, one extra layer, because it is metal shielded, and outside it will be like plastic cover. Okay, so here there is additional shielding which looks like a mesh. Here there is no shielding. So no shielding, obviously it will be less expensive and less bulky. Here there is shielding and there it is costly and it is more bulky also, and this is less susceptible and this is more susceptible. Okay, then comes VCN. Okay, so this question was actually asked for only 6 marks, and this much of and if you understand, right, whatever I've written, it is enough. Like in textbook they have written 4-5 pages. For 6 marks, if you write that much of content, it's of no use. So I'll just tell you what you have to write. First of all, what is VCN? Is virtual computer like network, right? So it is a hybrid network model that combines the features of both. What did we study? 2 kinds of networks. Can you remember? Yeah, that is this one, circuit and packet, right? So if you combine both, you will get one kind of thing, that is VCN, virtual. Okay, so how to draw this is again simple. Draw the hexagon. In all the edges you just put the switches, and these all are end systems. Okay, A, B, C and D. Okay, so in the question they have specifically told explain the 3 paces. Okay, so that's why I've written 3 paces over here. First one is setup pace. In setup pace, what will happen is we will establish one path, like okay, if you want to send data from one point to another point, I will just tell that one particular point that this is the way, like this only you have to go. Okay, that let me explain now. Okay, so for that I have taken only one example. See, I have taken one router. Now I'll just tell that if data is coming from this side, okay, one should come this from this side, two will be going. Okay, this is nothing but the router. Okay, router or switch you can tell. So I'll make the work easy by giving it one table. Table is like nothing but incoming. There will be some incoming, and let us assume that this 2 is outgoing. So incoming, outgoing. So whatever incoming will be there, right? So it will obviously have port number, and this is VCI, that is value. Okay, whatever data value we are going to transfer. So port number is 1 and 1, 1. Whatever data we have, it can be 14, I have written here, and 77. Similarly, you can take another numbers also. Numbers doesn't matter. Just write incoming and go outgoing with port number and value. Okay, so that is only in setup pace. Then comes the data transfer pace, where data is sent in one particular path that we are going to show, like from source to destination. So now I'll consider big one. So just like for one switch we had this thing, right, the table. Similarly, for every switch we will have the table. Same thing, you have to just make one table and just tell that from source to destination I'm going to share the data. Okay, how it will happen? It may go like this, it may go give it to this, then go here and then here. This is what you have to explain. Okay, that's what happens in the data transfer phase. Next is teardown phase. Before teardown phase, we have acknowledgement phase. Acknowledgement is nothing but, now let us assume that you wanted to send this 14, okay, to this. Now let me say it goes and 14 you will reach here. How this will understand that okay, I wanted 14 only? There must be something like there, we have to inform this before only, that whenever 14 comes you should receive it. That is only acknowledgement. Okay, I just inform it that okay, this is the number that you should be receiving. Once it receives, there must be something that goes back and tells that yes, I have received. Just like in WhatsApp, once we read the message we get blue ticks, right? Same thing. Okay, I hope this is understood. Now in the middle of the path, there can be delays also, right? So these delays can occur in setup and teardown phase. So for like delay, there is one formula, that is 3T. T is nothing but the time taken to be transmitted from one link to another. Then is 3TO. 3TO is nothing but the time taken for packet to travel across the physical distance. Okay, and this setup delay and teardown delay, you already know what it is. Next question is, note on encapsulation or decapsulation from source to host, they have asked. Okay, so in the question I would like to clarify one thing, like encapsulation and decapsulation we have to explain from source host. Only with respect to source host they have asked, but I have written explanation for like what happens in source, what happens when it comes to router, and what happens in case of destination. All, I mean, if you understand source, no, you can write explanation for everything. So I'll just explain the source only. Okay, even in exam also they have asked that much only. In case if they ask extra, also you should be able to explain. And like DBMS was the paper where we had to do it, right? Like it was tough. They asked a lot of queries. So but I would like to clarify whatever query I had like I explained in the video, right? Same question appeared for 20 marks. So that's why every question or every extra things that I say, please pay attention. So encapsulation at source end. So same thing, okay? ATNDP, and for each layer something gets added. What is this something? You will understand. Okay. So first let me talk about application layer. Okay. Whenever it is source side, the arrow mark will come downwards. Okay. So application side, you already know whatever the data is transferred in application layer is called as message. So what will happen? So when it is in application layer, it will not have any numbers. That is nothing but we call it as header. Header will consist of source and destination value, from where to where it should go, the data. Okay, even if it doesn't contain any such header, we still will send it to the transport layer and we still call it as message only. Okay, even if it doesn't have what? Header. Then comes transport layer. So here the data whatever is transferred, that is called as payload. In simple, in case of encapsulation or decapsulation answer, what we are supposed to explain is what kind of data is getting transferred and what is happening. So in transport layer, there is a control, that is flow control, error control or congestion control can happen. And the result after whatever the controls are checked out, that whatever the packet we are sending to next layer, that is called as segment in case of TCP and user datagram in case of UDP. Okay, next comes the network layer. In network layer, we call it as payload. Now again in header and footer will be added and the resultant is called as datagram. See, this all you can remember, right, from this one. This diagram would have told. This is the trick to remember. Like if you know this, right, TCP IP, you can write any questions related to TCP IP explanation. Okay, then in data link layer, again they'll ask header and all, but remember in data link layer we will also add the next hop address. That is the speciality. Then it comes to physical layer. Okay, last layer. This is what they had asked regarding the encapsulation. Now we have to explain the decapsulation also. See, encapsulation is nothing but there will be one particular thing, okay? This is the data. We need to protect it. So I'll just go on adding header, footer, next layer of header, footer. So I'll encapsulate it. Okay, just like you have a chocolate and you are wrapping it with a wrapper. That is only encapsulation. Now I'll explain decapsulation. Decapsulation is nothing but you are going to remove one layers one by one in each one. Now how that will happen? Let us look into that. Okay. Yeah. Decapsulation. For decapsulation, see, remember, for encapsulation arrow came downwards. For decapsulation arrow will go upwards. Okay, so physical layer you already know. So I'll start explaining from data link layer, then this and this. So first is in data link layer. So in data link layer what will happen? The frame it is received, right? So that will remove header and extract whatever the information is there and send it to next layer. What is there in after data link layer? We have network layer. Now network layer will also do same thing. It will remove the header and the header information, extract it and send to a transport layer. Now transport layer it will send to next layer, that is application layer. If you check application layer, you will get the message. Same thing. Okay, in question they did not ask router explanation, so I did not explain. But it's better if you write router explanation also. It is just again 2 lines. Okay. So you can write it together. So in encapsulation and decapsulation of router, only data link layer and network layer is involved. Okay, fine. Then we have 4 basic topologies. Okay, very important question again. The first one is mesh topology. Remember, it is in star shape and we have 5 nodes which is connected with 10 links, and example is telephone network. So in this case, every device is connected to other device, and the formula is n into n minus 1 by 2. How is this is, see, for one device it is if it is n minus 1 node, for two device it will be like n minus 1 node only. Similarly, for n device it is n into n minus 1 nodes. Okay, advantage here is, for advantage I have a trick here. Okay, it is DFSR. D stands for dedicated links, fault resolution, secure and robust. And disadvantages also, it is ECE, expensive, complex installation and excessive cabling. Second one is star topology. So this entire thing we call it as hub. So each in the hub, like computers will be connected individually. Okay, so by looking at this, what is the advantage? We can connect it easily, so easy installation. And if one device fails, others keep on working. But here in this thing, if one, it may affect the other. Okay, that is the advantage. And but the disadvantage is, if the entire hub fails, then all the devices will not get the connection. Example here is LAN. Okay, then we have bus topology. In case of bus topology, we have two cable ends, and these are the tap and this is the drop line. Okay, how this works is, all devices are connected to one single backbone cable. Okay, and the advantages is it is easy to install. You can see less cable, so no mesh. And disadvantages, if the backbone only fails, then everything will fail. Example is early Ethernet LANs. I've seen many people writing answer for this question, but the thing I could observe, or the missing content was, they did not write the examples. Okay, that is important. Then comes the ring topology, where we will be writing in a ring. So ring repeater, that is how you can remember. Okay, here repeater will come. Okay, now what happens is, by looking at this you can explain, right? Advantages again simple, easy to install, fault resolution same thing. The disadvantage here is, suppose if one or if the ring breaks, then every device will be disconnected. Example is IBM's token ring LAN. Next is logical connection in TCP or IP. See, for this I'll tell you, logical means you should always remember the source and destination will be there, and LAN will be there, and in between that router. This is nothing but the layers from source to destination, whatever will happen. Source, these are the layers. I told you, right? AT and DP, application transport network data link and physical layer. And similarly here also, link or LAN is nothing but it will consider of data link layer and physical layer. Similarly, router, this is a part of router. LAN will have two layers and this is the destination. Now, to understand this logical connection, there is two concepts. One is end-to-end and hop-to-hop duties. Okay, end-to-end is nothing but three layers will be involved. That is first three layers: application, transport and network. So in case of ATN layer, we use end-to-end communication, and the device like one end device to another end device across network. That is how the data transfers. And in case of hop to hop, the host or the router is involved. This happens in next two layers, DP. Okay, when it comes to logical, please remember that switch, or the router and the LANs are involved, and you have to explain this. Now, how do you differentiate? Because we are writing verses. So the distinction is that the top three layers is, it will require internet, and the next two layers will require segment links. Okay, then also you have to tell about what the data units will happen in each layer. So we can just consider it together. In top three layers, these units are not modified by router or this link layers and all, but in like bottom two layers, that is data and p layer, the packets created by host can be modified by router but not by link layer. Now what is this router is, you know, right? Router and data layer is also called as data link layer. So when this is router thing, right? Router thing, this is nothing but OSI model. Okay, so this router whatever is there, right? So this router, at data link layer, this thing can be modified. That's it. Next one. Okay, by looking at this question you may be like, I've studied first module, I couldn't find this even in the syllabus. The thing is, they have given in model paper, so we can't neglect it, so I've written here. Okay, I'll tell this in the form of story so that you can remember it for a long time. We have to write the differences. So OSI versus TCP. OSI is nothing but open system interconnection model, and TCP is transmission control protocol, and IP is internet protocol. Okay, first you will write the full form and you will tell who developed it. This was developed by ISO. Okay, just make ulta. Okay, ISO you can see, and this is nothing but made by US Department of Defense. OSI will have 7 layers, TCP or IP will have 5 layers. I had shown you, right? You have to go like this during encapsulation. So that is top to down approach, and TCP is bottom up approach. TCP, P is what? Protocol. So this has protocols and this doesn't have protocols. This is just the conceptual model and this is the practical model. Now we have to tell what is the reason for OSI model to fail. Okay, the thing is delayed standardization, which means, see, these points you have to write and explain in a sentence according to scheme of evaluation. So if you can't use this exact words, you can remember this story and write as it is. So the reasons for OSI model failure was, like, the first reason was, even though it was made, it was not standardized, like it was not registered. Okay, actually in reality OSI model was first formed. Okay, later they formed TCP and they registered fast, but these, even though they had formed, they had not registered. And this is just theoretical and it consists of 7 layers, which is like complex, right? So that is why it is complex and theoretical model, and they even did not implement properly. Theoretical, right? So they did not implement properly, poor implementation, and the layers were more, so insufficient layering, and even the market preference. Since TCP got standardized first, people started using TCP more rather than OSI. Okay, that's the thing I wanted to tell. Then we have next one, that is describe operation of connectionless packet switched network with the diagram. Okay, now we have to just explain about the datagram. That is nothing but, you will consider one diagram. Okay, let us assume that this is the source A and this is the destination. Now let us assume that I want to send some data. Data is nothing but the packets. That is, we have 1, 2, 3 and 4. Now suppose, let me say I am sending this 1. So this one has the dependency, or it is independent, right? It can choose its own way. It can either go like this, it can either go from this router and reach like this. It can reach in any way. That is only we have to write. Okay, packets are treated independently. They can go in any directions. And these packets are called as datagrams. In place of switches, we are using routers. That is why it is datagram. Connectionless means routers, remember it. Okay, then each packet may travel in different directions. That is what you have to write. And but it will still have, I have told you, right, in VCN we had this routing table, right? So in routing table, each table will consist of the connections, like from where to where it should go. You have to explain that, like it will have routing table even though it is connectionless. Then the destination address, how it will receive. I have told you acknowledgement, right? Same thing you will write. And the delay formula is also same here. 3t plus 3, this should be 2. Okay, same thing we will write. Then we have to also write like explain what it is. Okay, T is transmission here, that is from one point to another point the transmission, and this T is called as propagation delay. That is nothing but the signal, like whatever the time it takes traveling from one particular point to another point through one medium, that is propagation delay. Propagation means one medium will be there. Waiting time is already known. Like in case of this thing I had told you right here, it will be in a queue, it will be waiting. So where is that? I think it's here. Okay, here it will be in a queue, so it needs to wait, right? So same thing, that is only you have to write here. Yeah. Okay, then comes explain classes of guided media. So we have three classes: twisted pair cable, which we already explained. Do you remember? Shielded and unshielded and all. Yeah, that is. Then we have coaxial cable and fiber optic cable. So twisted we have already known, right? Just for your revision I've written here. Write the same points. Then comes coaxial. Remember coaxial. Co means you remember like two. That means we have inner conductor, outer conductor, insulator, insulator. Okay, and this outer conductor is made up of foil or braid, and outside is the plastic layer for extra what is that? Extra, what is that? Yeah, the security purpose. Okay, to prevent from external environmental factors, that you can write. Then we have third type, that is optic fiber. I have written so much because we had it in physics, right? So you know what is critical angle, right? So if I is less than critical angle value, then diagram is like this: I is equal to and I is greater than. Just upwards on the line and downwards. Simple. Then we have optic cable. Okay, we will do the cladding, and this is the core through which the like data transfers that we have to write. And in case of mode, we have multiple and single mode. In multiple, we have step mode and graded mode. Single mode, nothing will happen. Simply it will go in one direction. What is this? This is this one. Okay, so it will go in one direction, and this is with the result that we get in the destination part. In case of graded, it will go like this, just like a snake, and it is a mountain. Just you can remember, graded means snake, and normal mountain what we used to draw in when we were kids. Step is nothing but it can, multiple things can go. Okay, and in the destination you'll receive kind of this thing. I don't know what to tell about this. Okay, then there are very small questions that they can ask, they may not ask. So you can just consider the first 10 questions from this module to be compulsory, and from 11 to 19 it is optional for you, but I would prefer, if you are aiming for 90 plus, please study. Okay, so purpose of cladding is nothing but will provide some extra like surface. Okay, this is only this thing, cladding, for some like protection, and we should make sure that light should be visible whatever the thing travels, right? That thing, I'm not telling the exact definition, I'm telling in the words that you will understand. So it will increase the refractive index, no signal loss, no attenuation loss, and no noise loss. So we have already studied circuit versus packet switching, that differences they can ask. Same thing, don't worry, but make it in a table and write. Then explain 3 switching methods they can ask. We already know circuit switching, packet switching, and third kind is message switching. Okay, there is no more explanation, there is just one line in the textbook also. So if you write that much, it will be sufficient. Then we have types of data flow. If it is simple, okay, that is called a simplex. Then the transfer is from only one direction. Data is transferring only in one direction. Example is transferring data from keyboard to computer. Half duplex is nothing but walkie-talkie. Okay, if one person is talking, another person should wait. Okay, and similarly, if this person is talking, another person should wait. So both can send and receive data, but one at a time. Okay, then full duplexes both can talk. Our smartphones, right? Like even if I'm calling you and talking to you, even if you're calling, I can hear. Like both can talk simultaneously and both can hear. Okay. Then there is some criteria necessary for effective and efficient network. The three criteria you can remember through the trick of PRS. That is performance. Performance means you should go to OS now. What all we had, like transit time, response time, throughput time, delay. Okay, even if you don't write these points, at least write that three important criteria, that is P for performance, R is reliability, and S is security, that is avoiding unauthorized access. Then this question they have not asked, but this was there in the most of the question banks given from colleges. See, point to point communication is two devices will be there, it will communicate from one point to one point. You can give the example of remote control TV, just like how you change this thing, right? It will get operated in TV, so that's what you can write. And then it is multi-point, like from one device you're going to connect to multiple devices and all should operate, and just like owning the lights and all. Just if you click one point, for example, if you consider Mysore Palace lightnings, somewhere one switch will get on and many things will get on, right? So something like that, not telling the exact one, but you should relate it. Then they may ask to explain the LAN. LAN is nothing but one switch will be there, and from one switch many computers will be connected. Like it will give the internet. That is, you can give, say it will cover only small area. Wi-Fi is the best example. Why Wi-Fi is best example? Because see, Wi-Fi, it will cover only limited area. Like if you have Wi-Fi's in your house, if you go somewhere up to maybe 100 or 200 meters, it will not take, or you will not get the fast internet facility. So that is the example for LAN. So it will only cover the limited area. It will give high data transfer only when you are in that particular area, and it can be owned and managed by single organization, right? So for one house also we will have, so single organization. Then last question is unguided media. Unguided is nothing but wireless. They will not have any specific media. In that we have three types: radio waves, microwaves, and infrared rays. In case of radio waves, see these values I don't prefer you to learn. You can skip it. Okay, remember radio waves. You can see the antennas, right? So that antennas is omnidirectional. Right? Okay, the simple thing I can tell is, if you have seen antennas anywhere, like why do we have it? For proper signal, it can go in any direction, so it is omnidirectional. And microwaves is only like one direction. For radio waves, for television broadcasting and all, we need this radio waves. Microwaves is satellite communication. It will have only one direction and there will be one certain focus point. Infrared rays is nothing but in case of remote controls and all, we will use it. If you want to remember these numbers, I have a trick for that also. Starts from kilohertz and ends from gigahertz. And lastly it is terabytes. Okay, terahertz, hertz. Okay, so 321, okay, 31, 1 300, then 300 to 400. Like this you can remember. And here I'll be ending the first module. Don't worry about the notes. I'll try providing it in a community post, and I'm hoping that I'll get the support just like I got it for the last time. All the best.